And when we talk about the definition of the derivative, what I want you to remember is that the derivative is actually related to the tangent line, where there's a tangent line touching the curve at a single point. We can use the derivative to find the slope of the curve by actually finding the slope of that tangent line. But since it's tedious to have to do it at any given point numerically, especially if we're asked to find the derivative of the curve at this value, and this value, what we're going to do is we're going to algebraically be able to find the derivative, and then after we found the derivative one time with all the messy math, then we'll just plug in the numbers into the formula that we get from it. So that's kind of where we're going. So the thing that I want to review with you first is just what is a tangent line anyway? And in geometry, the tangent line to a circle is a straight line that touches the circle in one and only one point, such as the point P that's shown on that graph there. The tangent line touches it in one point, not at any nearby adjacent points. It doesn't go through 2 points. It goes through 1 point on the curve. And the other requirement is that it indicates the direction of the curve. Okay? It actually indicates the direction of the curve. Now to clarify that a little bit, we're going to look at some tangent lines and some lines that are touching the curve in 1 point but are not tangent lines. Okay? For example, this line, which is going through the curve, going to the curve at point P1, the only place it touches that curve is at P1, and it does indicate that the curve has a positive slope at that point, because that tangent line also has a positive slope. We have a second tangent line at P3. Because it touches the curve only at the point P3, and it indicates the direction the curve is moving. It's moving. It has a negative slope, but it's only slightly negative. It isn't nearly as steep as the positive slope is here. For the moment, we're also going to have to discuss the restriction that it touches the curve in 1 point, which is what's happening at P2 and at P5. And it's also happening at P4. But P2 and P5 are not tangent lines. This is not a tangent. And this is also not a tangent. And the reason that it's not a tangent is because regardless of the fact that it only touches the curve in one single point, it actually bisects the curve. Bisect means it actually cuts it in half. It cuts it into 2 pieces. Okay? So those are not tangents. Now P4 does touch the curve in 1 point. It does fit the requirement that it gives you the general direction of the curve. But it does seem to violate the idea that it bisects the curve. that it cuts through the curve, and it actually does cut through the curve. P4 is a special point on this curve. P4 is called an inflection point. It's not the only inflection point on that curve. There's more than just that one. There's also an inflection point between P2 and P3, right along about here. We'll call that P2.5, since it's between P2 and P3. So both of those are inflection points. And the definition of an inflection point isn't really difficult to understand. It's the point at which a curve stops being concave down, which this part of that curve is concave down. It stops being concave down for just an instant before it switches to being what we call concave up. So concave down, you can think of the concavity of a bowl. The bowl is turned down, the water spills out, that's concave down. The bowl catches the water and holds it, that's concave up. Okay? And then the curve switches direction again at P4 and it begins to be concave down. Now it probably does some more interesting stuff before you get to P1 and after you pass P4. We don't know what that interesting stuff is because we can't see it. But the reason that P4, and actually if we were talking about it, P2.5 also, the reason those are kind of special cases is because they are inflection points. Okay? P4's line really is a tangent line. You just have to imagine making it short enough that it's only 1 point long. Okay? I know one single point really doesn't define a line, but what we're going to do is we're actually sliding the 2 points we know of so close together they're practically overlapping. So that's what actually allows us to call P4's line a tangent line. Okay? We need to distinguish between a secant line and a tangent line. A secant line does not touch the curve in just 1 point. A secant line touches the curve in 2 points. And it could potentially, depending on the curve, it could touch it in 2 or more points. But 2 is the requirement. So this is a secant line that we have here, and it connects the points A